Desmos is going to work. Hey, anytime it says sketch the function, don't worry about sketching it. I know you have it on Desmos, so you don't have to be a great artist by any means. That's okay if you don't. Let's see what Desmos has to offer. All right, so the first equation is y equals x squared plus aq. Okay, we get that. Y equals x squared plus 8x plus 16. Cool. And the other one, it looks like they cut off part of it, but it's going to be y equals negative 3x squared plus 6x plus 436. Says if supply function's that, demand function's that, find the equilibrium point. And so kind of have to find it. And I'm only looking in quadrant 1, so where these intersect each other. So our equilibrium point would be 10, 196. Hey, how's it going? Hey, doing well. Oh, for a Thursday, we'll take one of those. We'll take one of those. All right, so that's the answer to number 2. Should be relatively easy. So producing 10 items to have $196, and that might be just $196. Then the next one says the demand function is that. So again, I said the P is the Y value, so I'm going to just do in. Again, the beautiful thing about Desmos is it doesn't matter which form we have it in, it will solve for us. And then we have negative P squared, so negative x squared, oops, clear, plus 2q, or 2x, equals 0. All right, so we have a green. Oh, take a look at this. Finally, friends, you got yourself a sideways parabola. You know, there's always that one kid in Algebra 1 when you're grabbing parabolas. Does it ever go sideways? Yeah. When? Well, here's your when if you were that kid. All right, so the equilibrium point for this one is going to be 2, 39.9. Again, that's the beauty of using Desmos, because if you would graph that on the graphing calculators, I can't do sideways parabolas. It only graphs functions. It doesn't do non-functions. All right, and then it says if a widget company has total cost of the given, total revenues given by that, find the break-even points. If there's any of these that I did, let me know if you don't understand why something took place a certain way. 15,000. It's 150,000. 15,000 plus 35 x plus 0.1x squared. There's the first one. Second one, y equals 385x minus 0.9x squared. Okay, so we have both of those. So let's see what we can find. We got the red. Where's the black at? There's the black. All right, so somewhere in here. There we go. So at 50 items, I get 17,000. Hey, doing well. Good to see you, brother. And then in a monopoly market, the demand for a product is given by that equation where P equals price and X equals the number of units sold. What will be the maximum total revenue? Recall that R at X equals P at X. I can't see the whole thing. Can anyone see the rest of that problem on number 5? I'm not seeing. Can't see the rest of the equation. Can you? Number 5? Or do you guys have like a blank at the bottom 2 rows?
There's only an X and a Y value.
There's a what?
An X and a Y value, but that's it. No equation.
Oh, okay. Hard X equals P. Huh.
I might be on the wrong
I
thing.
think it's just the reduction function, which is like the price per unit.
That's my bad.
Okay. I'm not seeing where I would get an answer out of that because. Oh, actually, I do. Actually, I do. Okay, so our 2 equations are. Were you on the wrong page?
Yeah.
Oh, it happens. So we have this as one of our. So we have this given, but then they tell us that the other equation is y equals p at x. All right, so that basically means between those 2 equations, the above equation is our p-value. So what I could do is I could go ahead and plug this in. So I'm going to plug this equation here in for that p. So it'll be that parentheses times x. So it's going to become a parabola. So I'm going to go y equals parentheses. Hello. Oh.
Clear X.
Okay, this time. Maybe not next time. 175 minus, minus 0.5 x, and then close parentheses, and then it'll be times that outside x. Hello. Oh, friggin' gifts. I didn't get you anything. I have this kit. All right. Nathan, I don't think you're in trouble because it's folded sideways. It looks different. All right, so if we take a look at this function, it should be an upside down parabola, which it is. So if we find the vertex of this, so at 175, we get $15,312.50. So that would be our maximum price on that. Okay. All right, I'm on the back side, and I want to go down to the very bottom one because I just saw a grid that was there. It says, the owner of a widget factory rents his production room for $912 if 76 or fewer people attend, so the cost is $12 per person. For every person above 76 that attends, he reduces the price by 50 cents. Okay. So I think we can do that. So we have price, price, attendees, and then total. So they have 12, 76, and then 912. And so if we have 86, so he says that for every person above 76 people that attends the event, he reduces the price per attendee by 50 cents. Okay. So if it's going to be 50 cents less per person, if there's 86 people, that's 10 more people. So the price for this one will go to 7, and then I'll go 7 times 86. Somebody with a calculator do that for me real quick. 7 times 86. 602. Did I do that right? For every person above 76, he reduces the price per attendee by 50 cents. So 10 more people. Okay, so that reduced. And then Well, this isn't making sense. So it's $12 per attendee. We had 10 more people, that's $5. If I do 5 less than that, it goes to 2. Uh-oh, now it's doing this fun stuff. So that goes to, let's see, that's 2. Oh, look at this fun stuff that's going on. I think this problem is written incorrectly. Because I'm not getting the right price, because he would have a negative price for 106 people, meaning he's paying people to come. Yeah, I think this grid is off. So why don't you work on, let's see, take a look at number 6, profit function. We got that. Find the level of production, yields a maximum. So you're just looking for the top of the parabola. The profit function by the firms given by the next equation. Limitation space required production be capped at 100 units. So find the break-even point. So on number 7, you're going to have the parabola graphed, and then you're going to have a y equals 100 to find that. So 2 things graph. Number 8, retailer 80 widgets, wholesaler it's $350. Uh-oh, another gift card. Okay, Layla, you have a coupon as well. Thank you. So number 8, retailer 80 widgets, wholesaler price $350 and $120, price is $300. Wholesaler is willing to supply 60 widgets at a price of $280 and $140, price $370. Assuming the result functions linear, find the equilibrium point in the market. So we'll buy 80 widgets if the price is $350 and a $120 for $300. Okay, so we can do this. Let's just work number 8 together. Let's get rid of these. So first thing is I have to use the table to figure out the linear equation. So I'm going to go 80 and 350. And the other one I'm going to do 120 at 300. Then I'm going to do my little y sub 1 tilde. mx1 plus b. All right, so my linear equation is going to be, if I use y equals mx plus b, so I'm going to go y equals negative 1.25 x, and then my b value is plus 450. And then that's the linear equation that we're basing this on, with those 2 points. And then it says, assuming the resulting supply is linear, okay, find the equilibrium point. So 80 at 350, 120 at 300. The wholesaler is willing to supply 60 widgets. Okay, so now I have to make another linear equation. Table. So he's going to go 60 and 280 and 140 and 370. So move down a little bit, come down to the next one. This is x2, y2, so I'm going to go y sub 2 tilde m x sub 2 plus b. So it already graphed it for you, which is nice. So our break-even point is at 100 widgets, he sells 325. So those would be your 2 equations. So y equals negative 125 x plus 450, and y equals 1.125 x plus 212.5. All right, so I think you guys can handle doing 6, 7, 9, and 10, being we just did 8 together. Deal? And then tomorrow we're going to talk about health savings accounts, how they work. A lot of misconceptions how health savings accounts work, so I want to try and clear that up so you just have some knowledge of it later in life.